Let's do another example. I have here a circle and an angle drawn, and the angle's vertex is at the center of the circle. Now remember, we call this arc the arc that is subtended by this angle. And if this arc has length s, and this angle is, let's call it theta. Remember, theta is this Greek letter. And an important thing is that this angle theta is the angle in radians. And let's suppose that the circle has radius r. Then what we defined earlier was that theta, the very beginning of our radian discussion, is s divided by r. And so you can multiply both sides by r here, and we see that the length of this arc that is subtended is r times theta. So that means if you know r and theta, again theta in radians, then you can figure out the arc length of this arc. Or equivalently, if you know the length of the arc and the radius of the circle, you can figure out theta. So this is a formula that can be used to find arc lengths. And similarly, you can also find the area of this shaded region. So the area, we didn't talk about how to do this, but it's not too difficult to find out that this area is going to be 1/2 theta, again in radians, times r squared. Now I won't show you exactly why this is true, but I'll at least say that if theta is 2 pi, that means that you would be finding the area of the whole circle, then you get the formula for the area of a circle, because if theta is 2 pi, then this says the area is 1/2 times 2 pi times r squared, which is pi r squared. So from these, you can determine areas of sectors from these two equations. Let's go ahead and box them both. You can determine areas of sectors of circles and lengths of arcs of circles. So for example, if the radius is 5 and theta is 70 degrees, we can find the length of the subtended arc and the sector area. Now first note that in this problem, theta is given in degrees, so the first thing you'll have to do is convert it to radians. So theta is 70 degrees times, we'll do pi radians divided by 180 degrees, which I'll just leave in fraction form. There's zeros that cancel, and you are left with 7 pi over 18 radians. You can get a fraction if you want. I'm going to choose not to. Then from here, we can determine the length of the subtended arc. S is going to be r, which is 5 times theta, which is 7 pi over 18. So this would be 35 pi over 18. And the area of the sector would be 1/2 theta, which is 7 pi over 18, times r, which is 5 squared. So we would have 7 times 35 pi, well, not 7 times 35, 7 times 25 pi, divided by 36, which would be 175 pi over 36, which of course you could get a decimal representation if you wanted.